Tämä seuraava osuus on, vaikka nähtiin kaksi äärimmäisen mielenkiintoista keissiä tuossa nyt ennen taukoa, niin tämä jatko nyt on meille sillä lailla läheistä tekemistä. Me on otettu rooli markkinasta myytinmurtajana. AI on erittäin hypetetty teema ja yleensäkin halutaan lähestyä tekkiä erittäin maaläheisesti. Se tapahtuu parhaiten asiakkaiden kautta ja myöskin koestaa teknologiaa. Miten voidaan tehdä erityyppisiä tai ratkaista erityyppisiä liiketoimintaongelmia teknologian avulla. Ja kun tähän BilotGo Hackathoniin lähdettiin samaan viime vuonna kuin tänäkin vuonna, niin se oli meille kaikille seikkailu. Ensinnäkin siitä lähtökohdasta, että pitäisi löytää oikeasti semmoinen liiketoimintaongelma, joka on ratkaistavissa tekoälyllä, jossa kaikki tarvittavat elementit ja kriteerit toteutuu. Me oli paljon keissejä tänäkin vuonna, jotka ei päässyt maaliviivan tai ei päässyt lähtöviivalle, koska ei ollut kriteerit kunnossa. 3 keissiä kumminkin saatiin maaliviivalle ja ne on tosi kiinnostavia. Olen nähnyt nämä aikaisemmin ehkä vähän eri versiot näistä, mutta joka tapauksessa tiedän suunnilleen mitä on tulossa. Valtaosa teistä ei tiedä. Ja parasta näissä on se, että nämä on hyvin maanläheisiä ja konkreettisia esimerkkejä ja kaikki 3 keissiä erityyppisiä. Niin näillä sanoilla ja näppärästi kääntäen into English, Ashwin, Joel and the team to present case MetsäWood and EasyOrder.
Hi, I can start. My name is Ashwin Kumar and that's Joel Lohkanen from Metsä, and we're here to present the EasyOrder case for simplifying the order buying process.
All right, thanks, Ashwin. So a few pre-words before going into the actual case. About MetsäWood. So MetsäWood is part of Metsä Group, and I am representing Metsä Group here. So what do? We do products from sustainably grown forest. You can see here, I will not go through all the products, but for example, for construction industry, we do all kinds of things, custom things, bulk things. We do plywoods for industrial customers. And our kind of, or maybe enough of MetsäWood, but going to the whole group strategy, just wanted to bring this up and not go through the whole strategy itself, but especially the data part here. So kind of the reason or the underlying thinking around this case was that how do we create value from our data? Simple as that. And this is the showcase of the EasyOrder. A quick video here, only 1 minute, so bear with me.
The industrial wood business is complex. We deal with large-scale construction projects where every product order is customized. Delivery to construction sites at specified times is essential, and the pricing and terms of the industry are very complicated. While the rest of the world has gone online, it has been unheard of in our business due to its complexity. The result is that the industry still uses very traditional and conventional processes, where all transactions flow through a salesperson, from inquiries to orders to pricing and tracking to the final delivery and feedback. While this is a customer-oriented process, it's got several problems. We realized that this traditional process was not sustainable for the future, so we set out to transform it, to do what had not been achieved to date, to bring the entire transaction process online, taking the super complex and making it super simple. Welcome to MetsäWood Online, the first industrial end-to-end e-commerce platform for wood products.
Right, so this video was to put some context on what we started to build upon. And obviously, we have done our e-commerce. It is pushed to the market. A big part of our orders are coming already through this channel. But however, as always, there are some pain points, everything is not running smoothly. And this is the main pain points that we wanted to address with this case that Ashwin is about to present. The number one problem is the unavailability of stock. Of course, there are production planning processes and allocation processes behind it, why there is, in many cases, products that are simply not available when a customer places an order. And that causes other problems like intervention of sales, meaning that our salespeople are spending a lot of time trying to somehow fulfill the orders. Then kind of, in my opinion, as a bonus, in this case, we also discussed about having, well, not empty trucks, but trucks that are not fully utilized in the logistics sense. And these are the things that, and I feel that when we embarked on this journey, the vast majority of the time was actually spent on kind of narrowing down the problems, that this is what we want to tackle, and required a lot of discussions with the business and with the team. And from here, I will give the stage to Ashwin.
Yeah. Thanks. So speaking of the team, here is the team that was involved in this project. From MetsäWood side, there were 2 business development specialists, data and analytics, Joona and Jonas. We worked very closely with them, and of course, UL from ICT. Our team is over here on the right side. So let's start talking about the data. Just briefly, we had 2 main sources of data, the product master data and the customer purchase transactions. We had over a year's worth of transactions from 7,000 customers across 47 countries, and we applied a whole host of different algorithms to solve this problem. We'll get more into that later. The first step is to actually understand the business process that we're trying to integrate our solution into. As Joel just mentioned, there were a lot of discussions needed to really understand what is the problem and narrow it down to something specific. So a majority of customers who use the e-commerce portal, they log on and they check their past order and try to repeat it. Fairly straightforward because they're ordering wood products in bulk. However, this process fails when even one item in their past order is out of stock. It fails if there's one or multiple items out of stock. And what happens when this happens is they can't repeat the order anymore. Instead, they need to call the sales rep, see if the sales rep can help them figure out what to do next. Maybe suggest a different product, or maybe the sales rep can go and speak with the production plant manufacturer to see if they can actually speed up the manufacturing for this specific product. Another option they have is to just change the week. Instead of ordering for 2 weeks from now, order for 4 weeks from now and see if that helps. And the last step, if they can't do either of these, if they still don't get the answer, Joel.
Well, obviously that's the worst case scenario. There's a bad glitch in the customer journey, meaning that worst case is that the customer buys simply from somewhere else.
Yeah. And to solve this problem and avoid that kind of a catastrophe, we have the EasyOrder process. Okay? What is EasyOrder? It's a solution that comprises 2 main components, the Smart Recommender and the Truck Optimizer. We'll first start with the Smart Recommender. It's an intelligent order recommendation system that specifically tackles these stock availability problems. So there are a bunch of dots that connect the past order to the EasyOrder, and we're going to unravel those right now. Be prepared. Firstly, it's not just one EasyOrder. We have to suggest multiple. In our solution, we've built a solution that suggests 10 EasyOrders. This gives the customer the choice to choose which EasyOrder makes most sense for his specific situation. What does a past order look like? It's something where you have a few different product items and corresponding quantities. And the problem happens when one of these items, or many, are out of stock. So our solution entails two different approaches. One is replacements and the other is recommendations. The replacements is actually the key over here, because what the customer really wants is a replacement for this missing product. They're not necessarily looking for any fancy out-of-the-box recommendation. So to tackle the replacement side, we have two algorithms being used, the Gower Distance and negative association. Gower Distance is a really useful mathematical algorithm for understanding, for creating a distance matrix that helps you to map out the difference between the missing product, product C, and all the other products available. So if we look at the image over here, the black dot, that's product C, the missing one. And the green ones around it are the ones which are closest to it. The red ones are the ones which are farthest away. The green ones, those same green dots, are listed in the top 3 rows over here, aside from the yellow one. And what you can see is that the thickness, the width, the length, the sides, the patterns, etc., they're all quite closely matched to the original missing product, product C. And hence the Gower Distance score is very low, indicating that it's a very good replacement match. The one really useful thing about the Gower Distance algorithm is that it can work with numerical as well as categorical data, as is the case in this scenario. The next approach is negative association, and this is quite an infrequently used technique. It answers the question of what's a reasonable substitute for the product. So imagine that you have a goalkeeper, and that goalkeeper gets injured during the game. You need to substitute him. So you don't necessarily need another goalkeeper that has the same height, weight, or anything like that. You just need a goalkeeper that can get the job of goalkeeping done, a goalkeeper that can address the need of the situation. Similarly, over here, the top 2 rows, ID number 140 and 170, those two are the reasonable substitutes in this scenario. The thickness and the width are actually quite different from the original product, but it's addressing the need that that product was addressing. So this is just to contrast it with the prior algorithm, Gower Distance. This one is addressing the true need. All right, so that's enough about the replacements. Let's go to the recommendation side. We use 2 techniques over here, market basket analysis and collaborative filtering. The market basket analysis helps us answer the question of what would you typically buy if you are buying product A and product B. So, Joel, you're a breakfast guy. I can see that in your face. So, if you're if you're having milk and eggs, what else would you normally get?
Well, definitely not vegan bacon, but maybe bacon. Yeah.
Oh, good choice. Well, over here we have a similar kind of situation. We have product A and product B highlighted in yellow at the top, and here we have the top 4 suggestions of what the customer would typically order next, ranked in order of their lift score. So that's the market basket analysis. The next stage is collaborative filtering. This is a more commonly well-known technique used by Netflix and YouTube that basically understands your user profile and suggests products which would be which other users like you are buying. So these are products which you haven't yet bought, but others like you are buying. So are you interested? And these are also ranked in order of their score.
So it's based on customer segment, right?
Yes. So we have replacements and we have recommendations. But now there's one more step required, optimization. You have to optimize the balance of replacements and recommendations. Remember, we're proposing 10 easy orders. So for now, we've optimized it in a way which has 5 replacements and 5 recommendations, but this can always be adjusted. And beyond that, each of these replacements and recommendation products actually have different sizes. Some are bigger than the original, some are much smaller. So there's a quantity optimization at play as well. And in comes the truck optimizer. This is referring to the logistics inefficiency point that Yoel mentioned as a bonus feature in our solution. This enables us to use linear optimization to optimize the quantities of each of the individual products before recommending the final order. So if we look at some actual order example cases, the top two cases are ones with replacements, and the bottom two are ones with recommendations. But the quantity is always changing because the size of these products is different. And you want to fill the truck to its maximal capacity to utilize the capacity to the fullest. That's more efficient for the customer as well as in Metsä's interest. So now it's time for a demo, and let's actually see how the solution works. So we've created a web portal, which basically mimics Metsä's own e-commerce portal. And now if we log in, we can select the product group, let's say birch plywood, and now we select the week that we're interested in, let's say week 42. And now, normally they would go into their past orders. So just click on past orders. And now I can see what I've ordered in the past. The first one is from April, the next one's from February, January. Let's look at April. And let's try to repeat that order. But no, we cannot repeat it because the middle product over there is out of stock and is grayed out. So we're stuck in the process. Ordinarily, we would be stuck. But now we have an option to generate easy orders. So what happens when you click that? We have a whole set of easy order recommendations available for the customer to choose from. Let's look at the first easy order recommendation. All right. So this is an identical copy of the previous one, except that the out-of-stock product is now replaced by a new one. And yeah, this one doesn't look so bad, but let's look at the next easy order. Well, this is also a replacement, but this one's way too big, if you can see that thickness 30. Let's give it a thumbs down. It's way too large for us. Yeah, wrong size. And let's look at the next one. Okay, well, this one looks to be pretty good, right?
Yeah.
Yeah, let's give it a thumbs up. And let's add it to the shopping cart. So now you can see in action how the easy order process simplifies the buying process by solving the true problem, which was the inability to repeat the past order. Let's go back to the presentation. To put things into perspective, I figured it might be good to actually speak about this solution and where it fits on the analytics continuum. I don't know how many of you have seen this kind of a graph before, but anyway. You have business intelligence, machine learning, artificial intelligence, and there's a lot of confusion about which is what. So let's just say that the data that we used is the kind of data that we could get from a report. That's what you would get from business intelligence. We use this data to create models using machine learning techniques that understand the patterns within the data and enable you to make predictions, such as if someone buys product A and product B, there's a 30% probability that they will want to buy this other product. That's a prediction. But then we use those predictions to make optimized and automated decisions. 5 replacements, 5 recommendations, that's our optimization. And it's all done automatedly. So that part constitutes AI, when you automate the decision-making process. In addition, we also optimize the quantities in the truck containers. So to summarize, the 3 problems, which you all mentioned at the start, stock unavailability, intervention of sales, and logistics inefficiency, are addressed by the solution that we presented here today. And yeah. if you think about the benefits from Metsä side, maybe you all can speak about that.
Yeah, I would maybe sort of lift a few things up from the list, not go through everything. I think, first of all, the customer experience. That's hard to measure in a way, but anyways, our approach is that whatever it takes, we do. Although we are not with this solution, we are not fixing the root problems or root causes. And that's something else that we are obviously working on the side. But due to the customer experience, we wanted to go forward with this. And then, as already mentioned in the beginning, the value from data, as we are having a very kind of data-centric strategy, and we've done a lot of things with our data to get the foundation right. Now, these type of things are where we are actually creating some value. And then obviously, last but not least, is the corporate learning, that we also start to understand what we can do with these kind of machine learning and AI solutions. Those would be the three main benefits for me.
Yeah. Well, great. Thank you. It's been really wonderful to work with you on this project and your team. And big thanks from everyone here at Bilot for participating on this journey with us.
Thank you. And Ashwin, one last thing is that I think we were able to also change a bit on the Bilot slogan. So
that's true.
What do you stand for nowadays?
Well, nowadays we stand for wood.
Simple as that.
Simple as that, yeah. Are there any questions?
Let's first give a big round of applause to thanks for staying in your time budget. So,
oh, did I? Okay.
Yeah.
Good.
We have time for our, maybe one or two quick questions. And let me get the mic for you so we have recording this for improved customer service.
Okay, hoping that it's on. How good shape was your master data? Because you you had to have the characteristics in place.
Yeah, that was only what you saw in the slides. That was a small part of the characteristics. Well, to be honest, we learned also something from the data during this exercise, especially our product data. So we needed to do a little bit of tweaking. Some of the characteristics were concrete example were kind of embedded, for example, in the description of the product, which obviously is no good. So we needed to do some cleanup as well. But overall, I would say that our master data is in a fairly good shape. There's always room for improvement.
It could be a lot worse, I can say that.
Yeah,
it was not so bad.
And in this case, we're talking about sort of structured data, so that makes things a bit easier.
Any other questions?
Okay, well, I have an additional slide which I just thought I'll share. A few tips in case you're starting on this journey or in the early stages and you want to figure out how to ideate use case scenarios for machine learning. Number one, focus on what's important, time-consuming, painful, pretty obvious. Number two, don't worry too much about the data quality and data quantity issues. Usually it's a lot better than you actually think it is. And don't let perfect data be the enemy of good data. But the last point is the most important point. To figure out where to begin, start from the decisions, because the decisions that you make are made based on predictions that you're already making. So once you can identify which predictions you're already making, that's when you know where to start. Thank you.
All right, thank you.